All right, welcome back. We're still at task 5-6. This is the final triangle. This is where we are summarizing, generalizing, looking for patterns. Notice that I dropped an altitude here, segment CD. I'm going to call that H. And I'm going to look for some relationships between some of these angles ABC and some of these side lengths ABC. And the first one I'm going to start with is I'm going to find the sine of A. So opposite over hypotenuse is going to be H over B. Now another way to write this would be H must be equal to B times the sine of A. Okay, and then I can also look at B. The sine of B opposite over hypotenuse is going to be H over A, and I can also rewrite that as H is equal to A times the sine of B. Now given that both of those are equal to A, I can now write an equation that B sine of A equals A sine of B. Okay, so now I have this, and then I can rewrite this by dividing. I can write this as the sine of A over A must be equal to the sine of B over B. And this is, right here, is what's known as the law of sines. So that's one of the things you can derive from here. We can also use the cosine to come up with some other things. So let's look at that. So the cosine of A over here, A, is the adjacent divided by the hypotenuse. So this would be C over B. Now it's not really C though. C is the entire thing. So this is going to be the segment AD on my diagram. AD. Okay, and I can also say that cosine of B is going to be DB, that's the adjacent, over divided by A, which is the hypotenuse. Now, to find, let me go ahead and bring this up. I've defined C as the sum of the two segments that make it up, which is AD plus DB, and using these we can rewrite, AD as B cosine A, and we can rewrite DB as A cosine B. So now we can say that C is equal to the sum of those, AD B cosine of A plus DB, which is A cosine of B. So here's another property that we have found here to find the length of C. It's this nearest side B times the cosine of A plus the nearest side A times the cosine of B.